So welcome back. The concept I thought of discussing today is this one, like this. So until now we have implemented stack operations using arrays, right? The next one is linked list. There is nothing much to discuss about the linked list because when we are discussing about the time complexity, we have already discussed about the stack type of operation. That is the big O of one complexity insertion. So earlier, what we used to do is when we are going through stack linked list, we used to create a new node and we used to attach it to the last. But before that, we want to traverse along that one. So for example, if I want to insert a new node, where should I insert? I will start with the root and the traverser will be here, right? And after that, the traverser goes to the next, sees if it is not none, then it will go to the next, sees it is none. Okay, so when it sees it is none, then it will attach. So the traversers dot next is equal to new node. This is how the attachment will be done in a single linked list, right? So for big O of one complexity, what we have discussed, can anybody tell me? For big O of one complexity insertion, are we using traverser traveling from the first to last?
No, sir.
Yeah, what you will.
We are using other variable and, sir.
Yes, that is, for example, end or something. So now it is attached to end. And again, if you want to insert a new node, you can simply find where end is, because end is having the address of the last node, right? Maybe the address is 6101. So if end is a variable, it will be storing 6101, which is pointing to the end node anyway, right? Because you see, if you understand this one, there are two compartments in each node, and the rightmost compartment in your linked list, which we call it as the next address, is always equal to a pointer because it is holding the address of the next node. So instead of this, what we are doing, we are just creating a single one like this, which can hold, like your root holding the address of the first node, your end holds the address of the last node. So what you will do, you will simply create a new node, and later on you will say the end next is equal to new node. So it is connected, and end will be equal to the new node. So now the end will be pointing to this one, and maybe if its address is 4101, that will be copied here, 4101. Now the end is this, not this one, right? Again, if you want to insert a new node, you will find end, which is nothing but this one. Insert the ends next to new node, and end is equal to new node. That's all, the same way. Now, instead of end, what we can use to make it as a stack operation, can anybody tell me? Instead of using the name end, which name can be used so that it will become a stack operation?
Top, sir.
Top. That's all. Your top. So every time the top will hold like that, whenever you say push of some value, you will write the top will be equal to the next one. The new node will be created with the value that you want to insert, and the top will be now adjusted to 6 after connecting it to the linked list. So it goes on. So it's easy. Now you just try out. It's very easy for you to do it, because if you have tried out, it's also like big O of one complexity. It's very easy than traverser. Okay, so I have even told you the steps how to use it. So what you do is first create a node which holds the number that you want to push. So instead of inserting into the linked list type of function, you write push function. That's all, a small change. And there, what you will do, you will receive the end address. So you can say push end comma not end top comma 6. So you will create a new node where 6 will be the value and the next address will be none. Okay, There is no loop also. That's all. So you will say new node is equal to linked list of whatever that linked list class you will write that you will have. Like for example, maybe we are writing a value and a null. Okay, this is how you create. And after that, you say that and okay, now we have top, right? So top dot next is equal to new node and top is equal to new node. That's all. Now the top is now changed to the new node itself. So now everything is connected. These are the only few lines to insert, push something. What do you do in pop? This also you have done it right. It is equal to the deleting of the last node. That's all. And move the top to the previous position. How do you move the top to the previous position? How do you know the previous position is this?
Top minus 1.
Yeah, top minus one we will do. How do you? So it is not double linked list, right? If it is double linked list, it is very easy to go back. So when the top is here, when you want to delete this node, you can easily go back in double linked list. But how do you go back in single linked list? I hope you are understanding the problem.
Yes, sir.
Yes. So what is the solution for this?
Using traversal, sir, again.
Yes, using traverser, definitely. Anyway, for deleting, we don't have anything else. But if you invent some new thing, then that's also good. That's fine. You can go with the new things. But now I will tell you just I can go with the traverser and find out whether the next address is none for this particular one. We stop the traverser here, like the previous one. If the next address is none, what do? You will say top is equal to traverser wherever the position is, so that it is like top is equal to top minus one. So the top also comes here. And now cut the link, making it none. That's all. Only 2 steps for this. After loop, you write only 2 steps that will generally delete, pop out the linked list nodes like that. So I think now you understand how to do the stack operations in the linked list, which you have already performed most of the time. But the only thing this time you will work out with the top. That's all. So you can do it now as a practice. Okay. So with this, we have finished stack and array and linked list. Anyway, I will come with a program for this one also after you try out. Okay. But you should try out now. It's very easy. And you know how to try. The next thing is I have uploaded. So you have a bonanza of exercises. The first thing is the buildings. Okay. The next thing is the class stack. I will just explain what to do with this class stack creation. So clearly see the program that you might have taken a screenshot, right? In the earlier class, like in the previous class in the morning, I have done some class program for stack. So what here you need to do is you need to do the same way like that. But the thing is that the input is slightly different. You can observe it here. All the instructions are given as earlier, but the input is something like first I will give 5. That means I want to give 5 operations. These operations one by one, I will give it as a string. Okay, string means when you pass this one, it will come as a string itself. So what happens is that you should keep them all in a list of it's actually 6. Don't worry, in the test case I have given it correctly, but here I mistakenly wrote 5 here. It is 6 and I am giving 6 inputs. See 1, 2, 3, 4, 5, 6. See, a small twist in the program is that you should keep all this input which comes as a string into your list. Now, while reading the list, you see here I have clearly given the note. When you find push of 5, you should call the push function of your stack object. So in the morning we have discussed how we create the stack class and how we call the push function of that object, right? Everything clearly. So the same thing that you apply, but this time when you see push of 5 as a string from the list, because you are storing all the 6 operations in the list, right? One by one you try to read down using for loop. When you find push of 5, then that means you need to call push. but how do you know that the element should be 5? So I have given a small hint that you can split the string and find out what is the number that you need to push. So what you do when you find out this particular push in a string that you receive, you should be ready to call the push operation or the method. But how do you know that 5 should be the number that should be pushed? So you should implement all the mechanism in such a way that using Python, you should separate 5 from this string and convert it into an integer and call the push operation where you send that integer 5 in place of element. So you say push of 5 because you already got 5, right? So based on the string that you receive, your computer, your program has to decide which function to be called, and if it is a push operation, which number to be sent for pushing inside. And for pop and display, I think it's very easy. When you find pop in your string, okay, you can just separate it with brackets. You can use the split function of a string to separate the brackets away so that the pop and the brackets will be separated. So when you find the pop in a list of 0, then you can say call the pop operation. If it is display in the list of 0, when you are splitting it, the first element will be display or pop or push, right? Then you call that particular function. So like that you can do it. Not a very big problem. So I have given the test cases like this. The test case will contain the input 6. These operations will be sent as string. And see, whenever I call display, write down the same way that I have written display, because you see the output for the first display, it is producing 5 space 6 space 7, right? And in the next display call, in the 9th line, you can see it has displayed in the 5 space 6. So I think you understood this one. Any doubts in this question, in this exercise? Any doubts?
No, sir.
Okay, right. Let us go to the next one. Just a second, I will be back. So for building stack exercise, tomorrow night 11:30 is the last date. For the class stack creation exercise, 20th 11:30 is the last date. I think for brackets detection, it will be something like 21 or 22nd. You can see because it's VPL, it will be allowed. Let us see what is the last date for that. Yeah, it is 22nd 11:30 night PM. Okay. It's a wonderful question. It is a question that is posed in Amazon and Facebook. What happens is this one, given a string S containing brackets, these two, this type of brackets, return the minimum number of brackets that can be inserted so that the brackets are balanced. I think, have you ever seen this one, right? When you are programming sometimes, I think if you are experienced in C and C++ or Java, you will be mostly accustomed to it. For example, when I write something like definition, or what we say, some function, I open the bracket and say a comma b, and I forget to close the bracket and put colon and write some things here. What will be the error? Have you ever checked here? What will be the error it will place? At least you tell me what is the error there.
Sir, syntax error.
Yes, syntax error, but it will clearly give that the parenthesis is missing, right? One parenthesis is missing. You'll say
Yes.
it will say one parenthesis is missing, right? So in C++ also, or in C also, or C++, it will sometimes, if we say void function int a comma int b. So when I open the bracket and do something and I forget to close the bracket, it will say that there is a brace missing. So it will give it as an error that brace is missing. How do it know that these are the things that are happening? So remember, these brackets and braces are all put into the stack and it can determine whether everything is correct or not. For example, see this one, I will, yeah. So now tell me, how many brackets are needed to make it correct? Are there any brackets needed to make it correct, or is it sufficient in this case?
It is sufficient, sir.
Sufficient. There is no extra bracket needed. What about the next case?
It is also sufficient, sir.
Sufficient, because this is one brace. Okay, if you just rub it off, the next open and close, fine, right? So you have one open and one close, one open, one close, that's fine. So this is also 0. What about this one?
We may need
Yes, of course. We should need. So, for example, this is, we have 3 close brackets and 2 open braces. You cannot make like this, right? You cannot bring it forward and say, sir, 2 are sufficient, only 1 is extra. No, that is not the case. It is like
we
a
need
stack.
5, sir.
So, what we should do is that we need around what we say 3 open brackets and 2 close brackets. Total 5 parentheses we need, right? That's how you need to determine. What about this one?
One closer back.
One closer bracket. One, sir.
1. Okay, just the number is enough. Whether it is closed or open, that's not the case here. Just the number is enough. For this,
One, sir.
1. That's all.
One, sir.
So a simple hint is that you when this type of string is given, so it will be given as a string, right? So I will give a hint like split it into list. So now when you split it into list, you will get like this. Okay. So what I will do, I will go through each one. I will have a stack now. Now what I will do, I will send this one here because the top is at -1. Let me use this bracket. So it will be good for me to explain it. Right. What is it? So what I will do here, I will increase my top. So I will just drop it. So I will create a stack that is equal to the list that I got. So what is the list I got here? 0, 1, 2, 3, right? Total 4. So what I will do here also, 0, 1, 2, 3. That's all. So this will be -1. So this is another stack I am doing it. 0, 1, 2, 3. So I'm giving you hint and you decide what program and what loops you want to write. Discuss among yourself. Nothing is very difficult and nothing is very easy. Little bit of hard and intelligent work will give you the answer. Okay. Now what I will do, I want to insert this into my stack. So my condition, I will look into this because the top is at -1. I can directly do it using while else something. Okay, while else I will do. So I will increase my top. Let me make my top as red color. Okay. So I will increase the top and simply push it because it's a normal operation. There is nothing to compare. Okay. So I will push inside this one. Okay. Right. So this time I will go through. So here I will break it. So this is in the while loop. So here I will break. And next thing what I will do is I will go for this one. And again I want to insert it. This time I will see that if this is the case, is the previous one, see one thing you need to remember, this is the open bracket, right? If you have another open bracket, nothing to go down. See, one by one I will check and give it to you. I will just increase the top. I just push it inside it. I just push this inside it. That's all. When I pushed it, I just break it out and come to the main for loop and increase my pointer I to here. Okay. Now what is the parenthesis that I got? Can you tell me? Is it closed or open?
Close it, sir.
Closed. So now what you will do, every time you will check the bracket that you got, whether it is closed parenthesis or open parenthesis with the topmost value. So here, what is pointed by the top in your stack is actually an open bracket. What is pointed by I in the list is a closed bracket. So without pushing the closed bracket, one thing you can do is, because these are matching, these two brackets are matching, you just pop out this one. See here what I am doing? I'm just popping out. That means you have only one element left, that is nothing but this parenthesis. So this is already popped out because its matching close bracket has come down. Now I will break there itself and come here, because this is the last element, nothing to compare. Now I want to insert this one. So before inserting, if I just produce, if I keep like this, if I make top is equal to top plus 1 and insert this one and replace this, it's a waste of time, right? So before replacing itself, what I will do, earlier the top is this one, right? I will compare with this one. So the top pointing is an open bracket and the insertable value that you are pointing to is a closed bracket. So by this time again pop minus minus. So top will be minus because we are calling the pop. I will give you certain examples so that you will understand the logic which I am now getting through. So by this time the stack has no elements. So if you just return the length of the stack, that's enough, right? Because you are returning the length of the stack for this is 0. That's fine, right? There are no elements because the top is at -1. That's all. Now let us come down to the other problem, which you have this one. This problem I will take. This is a bigger problem, right? So I will go to the next board. So what I will do is, so this string is split into the list, like that I assume. So after you get the string, I will split it into the list. 0, 1, 2, 3, 4. Okay. When you split it into the list, the next thing that you need to do is, you will start your I pointing to here. This is your for loop pointing to each location of your list. And for every for loop, you will have a stack insertion using a while loop. So for that, what I will do, I will have another bucket stack. How many elements are there here? 1, 2, 3, 4, right? Okay. 2, 0, 1, 2, 3, and the last one is 4. I'll write it like this. This is -1, 0, 1, 2, 3, 4. See, after this, I will explain the another case also, so that by this time you will understand what should be that. Okay. The top is at -1 position, and because it is the first thing and there is no comparison, you just say top is equal to top plus 1. And in the stack of the top should be equal to the L of 0, whatever you got, because this is the first one. So what I will do, I will insert it into this one. That's fine. I have inserted. So breakdown. Once you insert something, once you position something in the stack, break the loop. And so this while loop will be broken down and it will again go to the for. By this time, your I will be incremented to the next one. So your I is here. Now, the first thing that you do is to compare. we have the top with a closed bracket and the inserting value is also the closed bracket. So nothing to do, you just top increment, that means you are pushing into it and push the bracket here and break it. So by this time the for loop will come and the I will be incremented to its next value. Okay, now you just again compare it. So by this time when the comparison is done, your top is actually having a closed bracket, nothing to do, just increment your top and put stack of top is equal to L of 2, whatever you got now. That's all. Right. Break it because you already inserted the closed tag. So break it and the for loop will increment the I and go to the next position. So you will have your next position here. Right. And after it comes to the next position, again you check with the top. And remember, the down position should always be the, see it now you find something very strange here because these two are slightly different. This one is an open bracket and this one is a closed bracket. Now you think that, sir, can we pop out? No, that is not the case. Always the downside one, like your large and smaller values, the down one should be open bracket and the topmost one should be closed bracket. Then only you can pop these two. So why I'm saying pop these two, because before inserting this, when the top is at this position, you just pop it, that's all. So these two brackets will not be inserted into the stack. But this is not the case. So definitely you should insert into it by increasing your top. I hope you understand. Did you understand, yes or no, up to this?
Yes, sir.
Yeah, you should understand the condition that this is only workable. This is only workable. That means if you want to insert something and pop out something, the downside, that means whatever the present top should be open bracket and the insertable one is a closed bracket. If this is at top, then what you do is without inserting this one, you can just pop out this so that the top should come here. So these two are removed. That means two brackets are already solved. But this is not the case where 2 and 3 is posing, because the downside one is having a closed and the upside one is open. That is illegal. So we cannot do it. We keep it like this only. And break, because you inserted it, break down and go to the next one. And here you see the open bracket, right? So what you do is you just increment the top, because when you compare with the already existing top, it is also open bracket. So you increment it and put it there. And stack of top is equal to this one. Now break out. Come down and return what is the length of your stack. The length of your stack is this one. So actually, sometimes the stack might be created with all nuns, right? The length will be always 0 to 4, that means 5. So what I will do is, after you come out of the while and for loops, from the nested loop, I will use a for loop. For I in range, I will create an empty loop, answer is equal to this one. For I in range 0 to top plus 1. So what I will do each time is answer dot append of that, what we say, stack of I, whatever you got up to top. So now your answer will be exactly carrying how many things are there. I will tell you when it will happen. Okay, let us take the next example. So this time I will take this example. Okay. So I have this one, and I think maybe something like this. So I will have a list of 3 elements. So 0, 1, 2, 3 elements. Now I will have my bucket here. the length is 3, right? Because to accommodate all, you will have -1, 0, 1, 2. The top is here. So what I will do is my I will be here. Okay. So when my I is here, because it is the first one, I simply go with top is equal to top plus 1 and stack of top is equal to L of 0. That means the list of 0. So I'll put the bracket here. That's all. So this is open bracket. And then break it, because you already inserted it, break it, and your for loop will be again catching up. And this time it is incrementing your I to the next one. That is the 1 index. Now what will you do? You need to compare with the top. Is it satisfying our condition? Say yes or no.
Yes, sir.
Yes, because there are lower element is 1 and the uppermost element is the closed bracket. That is the next one to be inserted. So naturally what you do, you just pop out.
No problem.
You just pop out. That means top is equal to top minus 1. So top will be now -1. Just break it. Because by the time you end that one, so break it and go back to the for loop. And your I will be incremented. Your I will be incremented. So what is now at this position? Because our top is top -1, so nothing there to compare. Simply by default operation, top is equal to top plus 1 and insert this one into this. So to make you know that I have a new bracket here. So by this time this is inserted. And that's all. That's the end of the program. Come down. So by this time the remaining are all nuns here. Right? Remaining are all none here. Nothing is there to insert there. So now what you will do, you need to produce only one bracket remaining. For that, you need another closed bracket. So your answer should be 1. So how do you get it? So I will write the same thing. I will write for I in range 0, comma top plus 1, and I will write answer. I will create answer is equal to a simple list, right? Answer dot append of stack of I. That's all. Nothing but stack of 0. It will end there itself because it will start at 0 and end at 0 because top plus 1 is 1 up to that. So naturally, what is the length of your answer? The length of answer will be 1. So this is what you need to return. See how many things we have written here. Here the length is entirely 5 because nothing is matching. So all the 5 need their own partner. And coming to this one, the previous one, coming to this, everybody has their own partner. So you got your length as 0. So you return 0. That's all. So it's a simple logic that you can say. So nothing to fear that much. If somebody has given you a string and asked you how many extra brackets are needed to have the partner for each of the brackets so that it will be fulfilled. By seeing it, you can easily say, but how does the computer know? You have to write this type of logic. This is where the stack uses. I think you understand this, and I will just show you the code now. Not code, of course. I'm sorry. This is the test cases. So these are the test cases I have given, whatever I have discussed now with you. Okay. So when a string comes, accept the string, split it into a list and do what are the logic that I have given. The output you have to return is the length of the final thing, right? Don't return the length of the stack because the stack is fixed size equal to your list. It will return the length always the size of the list, not. You should return how many brackets should be extra needed. So you should only go from 0 to top plus 1 and put it into answer and finally return the length of the answer like what I have shown you now. So this will be your answers. Just check out the test cases and see whether they are correct or not. And if there is anything wrong, that you can just report to me. Try these programs. Now you can start doing it.
Excuse me, sir.
Yes.
Sir, can you please upload the recording of this class after this class?
Yes, definitely. I need to upload even the stack programming also.
Okay, sir.
I will do
Thank
it.
you.
I will do it.
Okay, sir.
I will be right in a moment. For VPL, the virtual programming lab, it's very simple. Like you just use the input function. That's all. So after you take the input function, you just assign it to that S or some string or something. So just recap yourself how you have done previously and do it. Okay, then you do this one. We will meet in the
Sir?
next class.
Sir,
Yeah, tell me.
sir, I'm getting some errors. So can you see my, can you share my screen, sir? Once?
Yeah, you can. I will enable it. Okay.
Sir, while I'm running this code, getting correct answers, but I am while evaluating, I'm getting wrong answers, sir. Same code I evaluated, I'm getting wrong answers, sir. But if I evaluated, I'm getting this like answers, sir.
Yeah, once get down to the last one. Look into that. To the last case. Here, can you just zoom it? Yes, the expected outcome should be correct, but your program outcome is saying something like 3.
But sir, while running, I'm getting same expected output, sir. Once I run it, sir.
That's what I am looking into. Why it is saying like that? Give the same test case once. That open and that test case. Hmm. Why it is saying the program output is 3? Expected output is something like, okay, fine, but how your program output is coming to 3? Don't run it, just show me the code once.
Okay, sir.
Go down. Okay. Can you zoom a little bit? I'm unable to see. Okay.
Actually, first I take an input, sir, and I convert into list and the array taken, sir. Then stack called, and this is the functions I use it, sir.
Okay. Come down. Where you are printing that one finally?
Your output, sir.
Yes. So actually, if you are printing top, self.top is equal to top plus 1. For example, if you are trying to print like top plus 1, if your top is at 0, you are printing, okay. So if there is a 4, you are printing plus 1. Not a big problem. To debug also, nothing is there here. Outcome, it says the program output is 3 bus. If you're running individually, it's fine. Can you just go up to the test cases, another test case?
Yes, sir. Every
Go
test
up.
is showing like that, sir.
You are getting correct in the runtime and wrong in this one. Why I am unable to detect it? Could be this. Program output, expected output. It is printing something like +2, right? Every time. If it is 1, it is saying 3. If it is 0, it is saying 2.
No, sir, it's printing only the numbers output.
Huh?
Yes, sir, it's printing only the numbers, sir.
Yeah. I'm getting the output. There is no other else. There is no other print, right? Just show me if there is any other print that you have in the
No,
code.
sir. Only one print, sir.
Have you saved it after any modification?
No, sir. I saved it and run, sir. I get these outputs, these result, and then I run it, sir. I getting the correct answer, but in test cases, we're getting the wrong answer, sir. After running, I didn't modify anything, sir. After evaluating, this is the only print statement I kept in my code, sir.
Can you just send me that code in my WhatsApp? I will test it. Okay.
Yeah, okay, sir.
Yeah. You can stop sharing the screen and you can send the code to my WhatsApp. I will test it and get back to you later.
I have sent it, sir.
7? You're saying
Sir,
something?
I have sent it, sir. It's telling.
Okay, fine. I will see it.
Yeah, okay, sir.